All right, we're going to get ready for this Unit 7 test. As I look at these questions, the first thing that I notice is lots of zeros on these multiplication problems. Some of them have 1 0, some have 2. And if you remember our strategy for dealing with zeros, maybe these questions might be easier than you think. For example, if I just forget that this 0 exists, I can just say 3 times 4. Not too bad of a math fact. 3 times 4 is 12. I just have to remember to put my 0 back on when I'm done. The answer is 120. Here I have 40 times 7. Once again, I could forget the 0. And then I just have the problem 4 times 7. I'm rewriting it just so that you can see that it is just one number times another. 4 times 7 is 28. The only thing that I have to do is remember to put my 0 back on when I'm done. The answer is 280. As I look at this 80 times 5, once again, to get rid of the 0, I can take 8 times 5. I know that that is 40. I just can't forget, even though I have a 0 here already, that's what 5 times 8 is. That doesn't mean that I put the 0 in. I still have to remember that 0 that I got rid of to put that in there. The answer is 400. 40 times 60, I can get rid of 2 zeros, but I have to remember them eventually. If I take 6 times 4, I know that that is 24, and then I must remember to place both zeros on when I'm done. So the answer is 2,400. I would like you to complete these last 3 on your own. You might consider or think to yourself that this is harder because there are 2 digits. But if you want to, you could rewrite this problem as 24 times 2 and then put your 0 on when you're done. Sometimes it's easier to rewrite it because it might look just kind of weird with the 2 over here on the left, rather than being where it normally is, which would be underneath the 4. So if you want to rewrite it so it looks right, please do. It might help you get the correct answer. At this point, you could pause the video to do those 3 problems. That would be excellent. What do we have here? It says, solve each of the problems below. Show your work. You can use any strategy that makes sense to you, except repeated addition. So this problem here, 249 times 4, you cannot do 249 plus 249 plus 249 plus 249. That is repeated addition. You cannot do repeated addition. So I'll give you 3 different versions. Standard algorithm. First thing I'm going to do is take 8. Oh, that's not what I wanted. I'm going to take 8 times 4. And then I'll take 8 times 2. If I need to carry, make sure you do. 8 times 4 is 32. Carry the 3. I have to remember to add this eventually, right? Now I can take 8 times 2. 8 times 2 is 16. Plus 3, 19. Okay, that's one strategy, standard algorithm. Let's break this number apart. Some people might enjoy that. Is I can take 249 and I can put it in expanded form. So that would be 200. Let's see if I can color code this. Plus 40 plus 9. Okay, that would be if I isolated each number and I wrote it in expanded form. What is 249? 200 plus 40 plus 9. I can now take each of these times 4, and maybe you would like that better. So what if I do that? I'm going to take that 4 and I'm going to put it up into that problem. So I'm going to take 200 times 4. I'm going to take 40 times 4. And I'm going to take 9 times 4. Well, if you remember our zeros rule, 4 times 0 is 0, 4 times 0 is 0, we could just forget the zeros and just take 4 times 2. We know 4 times 2 is 8, and then I'm going to add both of these zeros. Hey, it looks like eyeballs. It's angry. And then I can say, what did I say? Yeah, bring my 2 zeros back. I got distracted. Let's see. Here, same thing. Forget the 0, take 4 times 4. If you do that, hopefully you will agree that you get 16, and then you put the 0 back on. And our final one is a math fact. 9 times 4 is 36. Once I've broken those numbers apart, I can then add them together and get my new or correct, or the final answer, I guess I should say. If it helps to stack them, please do. You could do 800. You could do your 160. You can do your 36. And then you can add them. I'm going to zoom in this way. First column adds up to 6. Second column adds up to 9. First column, or last column, adds up to 9. 996. That is a second strategy. We did standard algorithm. We have broken the numbers apart. For this one, I'm going to allow you to do this one. Do it on your own. Choose one of those two strategies. If you want to do something different, you absolutely could. If you wanted to draw like a tile array, you could. But I highly suggest you try one of the two strategies that I chose. Choose one of the multiplication problems below and circle it. Pick the one that seems best for you, not too hard, not too easy. Interesting. One of these might be not too hard or not too easy. As I look at these, I go, I see that one I kind of like. This would be, no. Really, this is kind of the one that I would prefer to do. So that's the one I'm going to circle because that's what the instructions said. Find the answer to the problem you circled and show all your work. So 12 times 14. First thing I'm going to do is write it down. And then I notice 12 and 14 are both even numbers, but I'm going to do the doubling and halving strategy. So I'm going to double this number, and I'm going to cut this number in half. Okay? If I do that, I end up with 24 times 7. Now I can stack them and multiply without having to do the standard algorithm for double digits, which is a little bit harder. 7 times 4 is 28. Carry the 2. 7 times 2 is 14. 14 plus 2 is 16. 168. There are other ways you could solve that problem, but I love to find ways to use the doubling and halving strategy because it's way easier. Remember, if you don't, what does that look like? Oops, didn't mean to do that. 12 and 14. When you do that, 4 times 2 is 8. 4 times 1 is 4. In the next row, you have to bring down the 0. 1 times 2 is 2. 1 times 1 is 1. Add that together. You get 8, 6, 1. You get the same answer, but there's way more steps. Being able to do it this way, to me, has less opportunities to make mistakes than if you do it this way. Okay? Of course, you can use your own strategy if you don't like that one. Fill in the bubble to show the best estimate. You're going to see that a lot on your final assignments for math in this unit. Best estimate. Well, I actually kind of like 25s, but I could say that's 30, couldn't I? We could do it a couple ways. Let me show you what I mean. I'm pretty good at multiplying 25s, so I could multiply 25 times 6. But that's also pretty close to 30. I could do 30 times 6. To me, each of those are not too bad, but maybe you would prefer 30 times 6 because you can forget the 0 for a second. 6 times 3 is 18, and then you add a 0 on, right? So it says, fill in the bubble to show the best estimate. So 180 is a little bit closer to 200 than 150, right? If I were to kind of just write this in here, I'm 30 away from there, but I'm only 20 away here. So I'm going to mark this one because that is the way that my math worked out. If I said y, I could simply write how I rounded 26 to 30. My answer was 180, and it was closest to 200. That would be my reason why. Okay? Because estimating is maybe just a little bit more abstract, I'm going to do this one as well. Hopefully you'll see that 31 is close to a number that we know, and 49 is close to a number that we know. If I were going to round them, that's easy to multiply. That's also easy to multiply. In fact, that looks a lot like one of the problems we did on the first page. I can forget these two and then focus on taking 5 times 3. We know that's 15. And then I have 2 zeros that I have to add now that the problem is over. 1,500 is my estimate. That's a pretty close answer. It's not exact, but it's really close. What am I closest to? Well, I'm actually spot on with 1,500. And when it asks you why, I would say something like this. 49 is close to 50. 31 is close to 30. Bada boom. That's my reason. We can hear workers out mowing the lawn in front of our school. There are 2 sections to mow. The first one is 24 feet wide and 49 feet long. The second one is 6 feet wide and 23 feet long. How many square feet of grass do they have to mow in all? So first thing they want you to do is to write an equation that represents it. Okay, and we can use a letter to stand for the unknown number. Okay, that would be like the square feet, the total, right? So let's set up. It looks like we have to calculate 2 different sets here because what do we have? Oh, this keeps doing that. Drive me crazy. If I make this just a little bit bigger, I'm going to draw 2 rectangles. It doesn't matter that they are pretty similar. We're just doing it for the numbers. One is 24 by 49. It'd be helpful if I wrote that correctly. The other one is, what does it say, 6 feet and 23 feet. The other one is 6 by 23. Okay, so we have 2 different rectangles. Since we're talking about square feet, we know we're talking about area. We know that area is length times width. Okay, so what would our equation be? Well, I need to combine the area of this one and the area of this one. If I'm going to combine these, I'm adding them together. So let's talk about the area briefly to figure this out. The area of the black one is 24 times 49. That would be the area of that one. Since we're combining them, I need to add the red one, which would be 23 times 6. It doesn't ask for the answer in this one. It just says write an equation to represent the problem and then use a letter to stand for the unknown, what's it say, variable? Number, the unknown number. My unknown number is going to be G for grass. So this problem says, if I take the area of the first rectangle and add it to the area of the second rectangle, I will know G, which is how many square feet of grass they need to mow. Molly got 1,000 for her answer. Is it reasonable? Why or why not? Use estimation. Whoa, we practiced that a whole bunch up here. So let's do it one more time. 24 and 49 are pretty close to, what if I said like 24 times 50, okay? And then if I look at 23 times 6, I guess I could round down, possibly. Maybe I could take the 23 and turn it into a 20, although I'm tempted to just leave that number alone, but let's not. Let's have fun with both numbers, and we'll say that that one is going to be 20 times 6, because that's really friendly. I like zeros. So if I do 24 times 50, I can forget the 0 and then just do 24 times 5. If I do that, 5 times 4 is 20, carry the 2. 5 times 2 is 10, plus 2 is 12. That's 120. Please don't forget that we must put this 0 back on, which means we have 1,200 would be our first estimated answer. So let's remember this number as we go over here and we look at these two numbers. If I'm going to look at 20 times 6, what I would do is just stack it. Forget the 0 for a second. 2 times 6 is 12. Put that 0 back on, 120. Now that we have both of those rectangles, the black rectangle and the red rectangle, I can combine them. So I have, I guess I can do this in blue, 1,200, 120, Add it down, you've got a 0, a 2, a 3, a 1. So our answer is 1,320. That's our estimated answer. It's not the real answer, but our job was just to do a quick, easy math problem to have a good guess. What did Molly guess? She guessed 1,000. Was she close-ish? Yeah, she was okay, I guess. If you don't think it is close enough, you could say no, and you could give a reason why, like I think it would need to be closer. Or maybe if you want to give her a break, you could say yes, and then you could say her number, maybe something like isn't too high. It's a little high, but maybe to you it's not too high. If you told your teacher, no, I don't think your answer is close enough, you could absolutely say something along the lines of, no, I think her number is too high for her to be correct. Now we actually have to solve the problem. So we now have to look at the black rectangle and the red rectangle and solve it for reals. So we do need, what does that say, 24 times 49. And then way over here, we need, what does it say, 23 times 6. 23 times 6. We'll forget that one for a second and come over here. Although this may seem like a lot of work, you could do standard algorithm of 2 by 2 multiplication, but we've spent so much time doing the halving and doubling strategy that I think we should do it again here. Cut this number in half, make it 12. Cut it in half again, make it 6. Now we have a single-digit number. However, if you cut it in half once and then a second time, you have to double this once and then double it again. How would I do that? If you wanted to add it, you could, if you didn't want to take it times 2. So you could sneak like a 49 in here and do a little addition problem. 9 plus 9 is 18, carry the 1. 4 plus 4 plus 1 is 98. And then since that's only doubling it once, now we have to double it again. Add another 98 on. 8 plus 8 is 16. Carry the 1. 9 plus 9 is 18. Plus 1 is 19. That's 196. Okay, so now that I have cut this in half twice, and I've doubled this twice, I'm ready to actually multiply now. Because what does my problem say? 6 times 196. And that we can do. Okay, so if I stack it, 196 times 6, make this a little bigger. 6 times 6 is 36. Carry the 3. 6 times 9 is 54, but don't forget to add your 3, which is 57. Carry the 5. 6 times 1 is 6, but if you add 5 to it, that's 11. So our answer is 1,176 for the black rectangle. Okay, so now we just figured out the area, which I believe is square feet. Is that what we're working with here? Let me see. Square feet. And let's not forget our units. Square feet. Okay, now I have to go over to the rectangle and see what we're going to do there. First, I have to find it. Where did it go? There it is. 23 times 6. So if I wanted to do that, maybe I could just stack it and multiply. 6 times 3 is 18. Carry the 1. 6 times 2 is 12. Don't forget to add the 1. So you have 13. And this is in square feet as well, because we just did area. Anytime you multiply length times width, you're going to have an area. Area is always in square units. Okay? So that 138, okay, is our answer over there. 138. Now that I know that the area of the black rectangle is 1,176, I can add that to the red rectangle, 138, and I will have the precise answer. So let's do that now. And I'll do that in green. 1,176 plus 138. Combine the areas and you will be done. 8 plus 6 is 14. Carry the 1. 7 plus 3 is 10. Plus 1 is 11, so you got to carry another 1. 1 plus 1 plus 1, 3. 1 plus nothing is 1. So my answer that you're going to be writing down in this blank here is 1,314 square feet of grass. Now that we've done the problem that way, don't you agree that Molly's answer was maybe even a little bit further away than our estimate? Wait, no, that's not true. We got 1,320. Well, look at how close our estimate was. That's amazing. Our estimate was only 6 off. Yeah, so that's good. Let's keep going. It says shade the bars to show each fraction. Maybe I could make this bigger so you could actually read it. There we go. Shade in the bars to show each fraction, then complete each statement with less than, equal, or greater than to compare the fractions. This is going to be really good for the test because this gets done in the checkpoints and in the final test several times. Well, let's start doing some shading, don't you think? So if I come in here with our first problem, make it nice and big so we can see it. Get my highlighter ready. 5/6. So that's what I'm shading. 5 of the 6. There's 1, there's 2, 3, 4, 5. And then on my next one, 2/3. So that's 1, 2. Visually, we can see by following, this line here that 5/6 is larger. So when we draw this, you just need to make sure that the alligator eats the correct number. Okay? If I move over to 4/6 and 3/4, once again, that's not what I wanted. This says 4/6, so 1, 2, 3, 4, and then 3/4, 1, 2, 3, and I can see once again, just by looking at the bars, that 3/4 is larger than 4/6, so I can allow the alligator to eat the larger number. Okay? Sketch and name 2 fractions that are equivalent to 2/3. So they already did 2/3 where they took this and they shaded in 2 of the 3, they wrote 2/3. You've got to figure out a way to write in your own. One way would be to double and then triple, or you could think of it as doubling and then doubling the double. You choose. You draw less lines if you do it my way. Okay? So let's think about this. If I were to double the 3 and the 2, double 3 you get 6, double 2 you get 4. So this new fraction would be 4/6. However, if I wanted to triple this one down here, triple 3 you get 9, triple 2 you get 6. So this would be 6/9. Now we just have to make the pieces agree on the left. My first one says 4/6, so I'm going to cut each one of these in half to get 6 pieces. So that one, there's 2 there, 2 there, 2 there, and when I count all of these, I now have 6 pieces. How many do I shade in? It says to shade in 4. 1, 2, 3, 4. What do you know? It looks the same as the one above because they are fraction equivalents. 2/3 and 4/6 are the same. Let's do this one here. I need to divide this into 9 pieces. I have 3, so I'm going to add 2 lines to each one. 1, 2, so that I have a total of 9. 1, 2, and then 1, 2. And if you count all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, I now have 9 pieces, which matches my bottom number. And how many do I shade in? 6. 1, that's not what I wanted. 1, 2, 3, 4, 5, 6. And once again, because we did our fraction equivalence correctly, what I shaded in perfectly matches. We are going to, on number 8, rewrite each pair of fractions with a common denominator. You can use the fraction bars to help if you like, then complete the statements with your greater than or less than. On the tests in those last checkpoints, they don't give you bars, but we can use them if we want, okay? For example, this says that we're looking at 1/3 and 1/2. We need a common denominator. We know that the bottom numbers are the denominators. We need a common denominator so that they match. You have to ask yourself, what can 3 be turned into? What can 2 be turned into that are the same? One way to do it would maybe if I called like this side the red side, I could count by 2s and go 2, 4, 6, 8, 10, 12. We'll just do a handful of multiples. And we'll call this the blue side, and I'll do multiples of 3. 3, 6, 9, 12, 15, 18, okay? I see that both numbers, okay, the 3 and the 2, they have a number in common. Did you see it? I see a 6 that is common for both numbers. You may have noticed that 12 is also a common number, but it's nice when you choose the smaller one if you have more than one. So the smallest number I have that's the same for both is 6. So I know that my bottom number is going to be some sort of 6. Okay? Now the question that I ask is, how do I turn 3 into 6? Well, I know that I need to take it times 2. If I do that, I must take the top number times 2, which gives me a 2 on top. If I look at the other side, how do I turn 2 into 6? Well, I need to take 2 times 3. If I do that, I also need to take the top number times 3. 3 times 1 is 3. I now have 2 numbers that have been turned into fraction equivalents that have the same denominator, which we call a common denominator. Now we can compare them. So down below, which one is bigger? And you can see that 2/6 is smaller than 3/6 because 3 pieces of this size is more than 2 pieces of the same size. So I'm going to write my alligator here. But if you wanted to, you could technically divide your thirds into sixths and highlight. And you could divide your half into sixths by adding 2 lines. The problem is that it's hard to be precise. Okay? But just so that we can finish it, let's see. Blue would be 2/6, and red would be 3/6. And you can see 1/2, right? 1/2, which is the same as 3/6, is bigger than the other one. Okay. Part B, same thing. We ask ourselves the same question that we did on the last one, which is, if 6 is my denominator here and 4 is my denominator here, what number do they have in common if you count by their multiples? So if we call this the blue number and I count by 6s, 6, 12, 18, 24, 30, so on and so forth. And then if I call 4 the red side and I count by 4s, I have 4, 8, 12, 16, 20, blah, blah, blah. It goes on forever. But I've already seen that there's a 12 in common here and a 12 in common here. So I know that I can have 12ths and 12ths. And then I will have the same denominator, a common denominator for both numbers. How do you turn 6 into 12? Well, I would take it times 2. And if I did that, I would have to take the top number times 2, which gives me a 4. On the other side, how do I turn 4 into 12? Well, I need to take it times 3. And if I do that to the bottom number, I have to do it to the top number, which gives me a 3. Okay? We now have fraction equivalents because 2/6 is the same as 4/12. And I have a fraction equivalent over here. 1/4 is the same as 3/12. The reason we did this was to find a common denominator so that we can actually compare the number of pieces that we have. Because if I have something broken into 12ths and I have 4 of them, that is more than if I have 12ths but only 3 of them. So when I go down to compare these, I can write that 2/6 is larger because that's what we found here. Didn't mean to do that. I meant to point to it. Now, if you wanted to, you could divide this up, cut each one of these in half so that there's 12 pieces. And then I could add 2 lines to every one of these so that it's cut into 12 pieces. And then I could shade one. Oop, that's not shading, that's writing. I could do 1, 2, 3, 4. And then for the red one, I could do 1, 2, 3, because that's what it says, correct? This says 4/12. This says 3/12. We just said that this one was more. That's why we drew our alligator eating 2/6. That problem is now fine. Fill in the blank with the correct symbol. So if we're trying to figure out which one is larger, it would be helpful if we maybe wrote the fraction that goes along with it. This one is 50 hundredths. This one is 5 hundredths. If you think of pennies, 50 pennies versus 5 pennies, hopefully you would agree with me that 50 is more than 5. Okay? For question B, you kind of have to add a 0 here to make it work. Because if this is in hundredths, this needs to be in hundredths as well. 29 hundredths compared to 30 hundredths. It's kind of like money. If you just put a dollar sign there, who has more money? This side does. Because 30 cents is more than 29 cents. If I'm going fast, you can always pause, okay? Same thing here. I don't like that there's not 2 digits here. So I'm going to add a 0 so that I have 60 hundredths. And then what do I have here? 63 hundredths. If I compare them, I know that 63 is more than 60. If you do this one here, I'm going to ask you to do this on your own, but do your zeros rule so that you can compare them. I'm also going to let you do this one on your own, but make sure you do the zeros rule so that you can compare them. The denominators need to be the same if you're going to compare them. And I'm going to let you do the zeros rule on that one on your own. Last page. Thanks for sticking with me. Brianna and Lupe each got a strip of fruit leather. It's like fruit by the foot, right? It's not supposed to be as candy-like, but that's what you're thinking of, like a roll of gummy stuff. They're exactly the same size. Brianna ate 4/6 of hers. Lupe ate 3/4 of hers. Okay? We want to know who ate more. Okay? If you want to, you could sketch it, you could label it. Personally, I think since we just did common denominators, the best way to know the answer would be to convert them. So I'm actually going to write these in their appropriate colors. So I'm going to do 4/6 in blue for Brianna, and I'm going to do 3/4 for Lupe in red. I ask myself the question, if I wanted 6 and 4 to have the same denominator, what multiple of 6 and what multiple of 4 do they share? I remember the last problem, so I have a feeling that I could do this one pretty quickly, but still, we're going to do it the way that we should. So I'm going to count by 6s on this side. I don't like how thick that is. Let's see if I can fix that. There we go. 6. And then 12, 18. Let's see. I messed up my pen here. 24, 30, 36. You will never have to count more than that. That's way too much. But that's just so you can see that I'm counting by multiples of 6 because that's my denominator. Now I'm going to go over here and do the same thing, but I'm going to count by 4s. So I got 4, 8, 12, 16, 20, 24, blah, blah, blah. That's way too many because I already see by comparing these two, well, hopefully you see it too, is that I came across a common number really early, which is 12. Okay, they don't share 6s, they don't share 4, they don't share 8, but they both have a 12. Okay, so what I'm going to be doing is I'm going to be converting the 6 into 12ths, and I'm going to be converting the 4ths into 12ths. So I'm just going to write those fractions there and get them ready. Now I need to figure out how to do that. Well, in order to get 6 to turn into 12, well, I kind of need to double it, don't I? I need to take it times 2. And if I do that, I have to take the top number times 2. What is 4 times 2? You get 8. So 4/6 is the same as 8/12. This is good news. Now, if I want to turn 4 into 12, well, I'm going to have to take it times 3, aren't I? And if I do that, then I'm going to have to take the top number times 3 because whatever you do to the bottom number, you have to do to the top. I took 4 times 3. I must take 3 times 3. And if I do that, what do I get? Well, 3 times 3 is 9. Now I have another equivalent fraction. 3/4 is the same as 9/12. Can you see that these two numbers, 4/6 and 3/4, is easier to compare now that I have 8/12 and 9/12 because the denominators match. They have a common denominator now. And which one is bigger? Well, I have 9 of the 12 pieces here and only 8 of the 12 pieces here. So to me, 9/12 is larger because there are more pieces. And not only more pieces, but more pieces of the same size. So when I go up here and I finally fill in this in, because I did the problem first, now I can fill all this in. I did all the work. Yay! So this is going to go by really fast. So it says, which girl ate more? Well, who was 9/12? It was the person who had 3/4, which was Lupe. So I can write that Lupe ate more. And then when I compare the fractions, I can just mark that in there because I already marked it down here. It says use the sketches, labels, numbers labeled sketches or words. Well, we did that down here. So this problem is now done. Woo-woo! So sometimes when you see like a fraction problem where you're comparing two fractions that don't have the same denominator, maybe just hop down here and start doing the work that we did on the previous page. Okay? Ooh, what are we doing here? Label each of the marked points on the number line with two fractions and two decimals. So as I look at this number line, what are we counting by? So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we're counting in tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so it looks like you have 10 white, 10 gray, 10 white, 10 gray, 10 white, 10 gray. And then I just need to figure out what I'm going to. Oh, so it looks like this goes all the way to 1. Okay, so this would be like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Oh no, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.1. So we're counting by tenths. So that's going to be really tricky. So in my mind, what I would do first is I would mark each of these changes in color. Okay? Because I know every single one of those is a tenth. How do I know that? Because when I put those in there, this is a chunk is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm working with tenths. And if I'm looking at this one specifically, I could think to myself, well, if this is 1/10, well, this one has to be 2/10, which means this would be 3/10, and then 4/10, and then 5/10, and then 6/10, and then 7/10, and then 8/10, 9/10, and then 1. Now, I didn't need to fill out all of them, but guess what? I just checked my work and I answered 2 along the way. Now, it says 2 fractions. 2 fractions. Well, there's a couple ways you could do this one down here. 2/10, I could simply just double this, and I could write 4/20. Or I could think to myself, ooh, both of these numbers are even. I could cut them both in half. What's half of 2 and what's half of 10? 1/5. I could do that as well. Okay, so those are both really good options. One is doubling the number, and the other is cutting the numbers in half. Okay, now, before we go on to decimals, let's just do our other fraction here. I cannot, unfortunately, cut these in half. Okay, because if you cut 7 in half, you get a weird thing going on here. So I'm just going to double them. Double 7, you get 14. Double 10, you get 20. So I have 14/20, and that's just fine. Now, what is maybe a little bit trickier about this? I'm curious to see if you can see maybe a better way to do both of the alternatives, the upper ones here. Because we could do some work down here, but really, I want you to think about it this way. 2/10, just written just plain as day, is 0.2. Couldn't we also just write 0.20, which is 20/100? Absolutely. Same for 7/10. 7/10 is 0.7. But if I want another fraction equivalent, I could just add a 0 to the end and have 70/100. One of the things that we could have done, had we started with the decimals, would be to write 20/100 as the second answer and 70/100 as the alternative fraction for the other one. Not saying that you have to, but part of me wonders if that's what they originally wanted in the first place. Okay, we got to finish up. We've got one more, and we even have a number line that we can use to help us. Max says 4/10 plus 35 hundredths is 39 hundredths. Ari says that that should equal 75 hundredths. So they have some disagreement. Who is correct? Well, let's just dig into this problem and do it this way. How can I add tenths and hundredths? By changing this number to match. Remember our zeros rule? Now I can actually have hundredths. What is 40 plus 35? Well, actually it's 75. So I disagree with this. Did Ari get the number that we got? Yes, Ari did. Ari got 75. So we can say, if I can get my cursor to move around, that Ari was correct. How do I know? Well, if you wanted to use the strip, you could, but you could also just rewrite our zeros rule from up here, and that would be just fine. If you have questions about this video, of course, ask a math wizard like your teacher. They love to help you. Otherwise, I hope you do really well on your test with your checkpoints in the future sessions. Watch this video as much as you need to. Later.